Hello everyone, welcome to the YouTube channel Mission at Physics Exam. And guys, today in this video we are going to discuss another part, or you can say the second topic of lattice vibrations, and that is the vibrations in 1D diatomic lattice. So in this case, what are the points you need to know, or the formulae which are very important and based on which you can expect the questions in the exam? Let's talk about them. Also, before starting the discussion about the topic, I would like to tell you one thing, that if you are new on this channel, then you can subscribe this channel. Also click on the bell icon after clicking on the subscribe button below this video, so that you will get the notifications for all the new videos I will provide you on this channel, and you will not miss any of the important videos. So now let's just start the discussion about the topic we are going to consider. Before this video I have uploaded, like just exactly before this video I have uploaded another video in which I have talked about the lattice vibrations in one-dimensional monoatomic lattice. Now we are going to talk about the lattice vibrations in 1D, that is one-dimensional diatomic lattice. Okay, so in this case we will talk about the formula related to diatomic lattice. Done. And if you have not watched the previous video in which we have talked about the lattice vibrations in 1D monoatomic lattice, please check it, because the formulae, the discussion we have done there, that will even be very much helpful for you. Okay, so just check that video too if you have missed it. Also, if you are new on this channel, or you have not subscribed the channel yet, so you can subscribe the channel too, so that you will not miss any of the important videos and you will get the notifications about the videos. So just click on the bell icon to get the notifications on. Okay, now let's talk about it. If I'm going to talk about the dispersion relation for the 1D diatomic lattice case, guys, dispersion relation is basically the relation between omega and k. So I'm going to write it here, omega positive negative, like omega plus minus you can say. Done. Here we are going to have the two different formulae. Just by changing the plus and minus sign you will get like two different formulae. Done. How? Let's have a look at this. So omega plus minus square, that's gonna be C into 1 upon m1 plus 1 upon m2. Now since it is a diatomic lattice, there will be two atoms. When there will be two atoms, there will be the different masses of the atoms even you can have. But any time if they are going to put any conditions on the masses of the atoms, you will make the changes accordingly. Okay, once you know the main formula, you can put any conditions and make the changes in the formula if in the question that has been mentioned. So the complete expression is one upon m1 plus 1 upon m2 whole square minus 4 sine square ka upon 2 upon m1 m2. Okay, and everything here is within the square root. Yeah. Now if we are going to talk about the further, like the discussion which we are going to consider and the important points, so they are going to be related to optical and acoustical modes. Okay, so in general, like in the previous video I have provided you the information and the formula related to the 1D monoatomic case. Okay, also in general when you want to know about the acoustical and the optical modes, okay, so I will provide you more information about it in the upcoming video. Even after this, one more video will be there where we will talk about the graphs for omega versus k for both the cases, both the topics which we have considered from the lattice vibration. Okay, so in general the acoustical, like I'm just going to tell you the statement here right now. For the acoustical branch, okay, when you will put k is equal to 0, when you will put k is equal to 0, then omega will be 0. But for the optical case, okay, when you will put k is equal to 0, the omega will be non-zero. Okay, so that's how like you can get some idea about the optical and the acoustical mode. Even this point can be a point from where they can expect, or like they can ask the direct question from you. Okay, so it is even a very important point. Make a note of this point if you don't know about it. If you already know about that, that's very good. Now next point here, in general, even we are going to talk about the optical branch. That was a basic information about the optical and the acoustical case. So we'll talk about the optical as well as the acoustical. You know, optical is related to light and acoustical is somewhere related to the sound. Okay. Now, if we are going to talk about the optical branch, the first formula, first of all, let me just provide you the information about it, that here we will consider the omega positive expressions, and for acoustical case you will write or focus on the omega negative expressions. So the first case I am going to consider here is that when k is tending to 0, that means k is small. Okay, instead of writing tending to 0, if you want to just write the small here, that's okay, you can write it. Clear? So even we can replace with this. So when k is small, then in that case what will happen? Or again, if you are more comfortable by considering 0, because further the calculation steps which we will take, they will be according to this. Done. And when you are taking it equal to 0 here, you will get it more clearly. Done. So instead of a small, I am just directly considering it tending to 0, or you can say equal to 0. Done. So now in this case what will happen, and why I have made this change, I hope you will get it soon, because I am going to use this expression in the dispersion relation. Okay, so when you will just consider it 0, what will be the omega positive value you will get? You will be able to get it as root 2c, okay, 1 upon m1 plus 1 upon m2, because I am considering it's like tending to 0, it's like equal to 0, approximately equal to 0, the k term. Okay, then sine 0 is equal to 0 itself. So you will just have this square, the complete square term within the square root. You can write it normally, take it outside the square root. You will have both the terms same, the first one and after the plus sign. So you will be able to get it like root 2c, okay, because you will remove this square from here. So you will get root 2c 1 upon m1 plus 1 upon m2. Done. After this, guys, when we are going to consider at the brilliant zone boundaries, so you will consider k tending to, or k is equal to, that's more better, plus minus pi by a. Okay, both you can take, plus minus pi by a. Then the omega positive value, after just putting that value here at place of k, you can check it, even do the calculation steps, you will get it same. You will get it equal to root 2c upon m1, where I would like to tell you one point. M1 mass we are considering is less than the M2 mass. So there are two atoms and we are considering mass of one atom, which is M1, is less than the other one, that is M2. Okay, that condition we have considered. And here in the omega positive formula, this is M1 I have written. Okay, so it's gonna be that the in optical branch, the value of omega is dependent on the small or the lighter atom mass. Okay, that is M1. So it's basically root 2c upon M1 at the brilliant zone boundaries. Now, if I'm going to talk about the acoustical mode, the omega negative expression you will consider, and at the center of brilliant zone, basically when you say k is equal to 0, that is the center of brilliant zone. When you will take k is equal to 0, you will be able to get the omega negative equal to 0. When in the starting I have told you about the definitions or how to check whether it is optical or the acoustical mode, I have told you that acoustical mode will be the mode for which when you are putting k is equal to 0, you will get the omega value equal to 0. So from here that point will get more clear to you. But in the optical case, the value of omega will be non-zero even when k is equal to 0. So the first case in the optical, okay, this case you can see when even you have considered k is equal to 0, instead of tending to 0, you can even put it equal to 0 exactly. That's more better. Okay, now you are getting the value of omega non-zero. So that is what optical case. Done. And acoustical cases, k is equal to 0 is going to give you the omega is equal to 0. Next point, when you are considering, this was your first point related to k is equal to 0 value. So you should write like firstly k is equal to 0, then write the omega value you are going to get. Second case is when k is small. Okay, k is small. Now in that case lambda will be large, and when you are going to consider or replace the sine square k upon 2 with the ka upon 2 square, because you know for k small, the sine square theta will be theta square itself, or sine theta will be theta. Okay, so accordingly you can make the changes, and you will get, after considering that, you will get omega negative is equal to root c upon 2 m1 plus m2. Okay, and into ka. Now if anywhere required, you can get the group velocity and the phase velocities easily. You can just find the d omega upon dk for this expression of omega to get the group velocity, and omega upon k for this expression for the phase velocity. Now next point will be at the boundaries of the Brillouin zone, that is k is equal to plus minus pi by a. What you will get, you will be able to get the omega negative value that will be equal to root 2c upon m2. Okay, so from here you can observe that the omega value is dependent on the heavier atom mass. Okay, so in the acoustical case how it is dependent, in the optical case how it is dependent, it's very important. You can expect the question based on it in the exam, and even like each and every expression we have discussed here is going to be very important. Further, we will talk about few more points related to this topic in our next video. So don't miss any of the videos. They will be very important. Okay. And I hope that each and everything which we are going to discuss or we have discussed till now will be clear to all of you. If you are having any suggestions, anything like any particular topic you want me to discuss, you want me to discuss in upcoming videos, you can mention it in the comments. I will try to consider those topics depending on how important they are, and we'll try to consider them too, but you can mention them in the comments. Okay, and you can let me know about it. Thank you so much everyone for watching this video till the end. Also guys, soon revision courses will start on Unacademy Plus for your upcoming CSIR net physics exam preparation. And if you want to attend the more regular live classes by all the top educators we are having on Unacademy Plus for your upcoming CSIR net physics exam, then you can take the Unacademy Plus subscription, because Unacademy Plus subscription will help you a lot to do the best preparation for your upcoming exam with the guidance of all the top educators we are having on Unacademy Plus for your upcoming CSIR net physics exam preparation. Also guys, once you will take the Unacademy Plus subscription, you will get so many benefits like weekly quizzes, doubt clearing sessions, mock tests, PDF of important notes will be available to you, and all these things together will help you a lot to do the best preparation in the remaining time before the exam. Also guys, let's say if somebody is going to take the subscription right now, okay, and any course is already going on, then you will even be able to get the recordings of the classes which have been conducted in any of the courses till now. Okay, and you have missed them, so you will be able to cover up each and everything with the recordings. Okay, and you will be able to watch the sessions like the upcoming classes, the ongoing courses and all for that much duration for which you will take the Unacademy Plus subscription. So you can take the subscription, you can use and apply the referral code, that is Anjali Arora, as it is mentioned here, because all these things together will help you a lot to do the best preparation for your upcoming CSIR net exam. Okay, no space in between, spelling should be same, that's how you need to write it and apply it. Okay, thank you so much everyone for watching this video till the end. Also, if you are new on this channel, you can subscribe this channel. Also click on the bell icon to get the notifications for all the new upcoming videos I will provide you on this channel, that is Mission Net Physics Exam, and click on the bell icon after clicking on subscribe written below this video, so that you will not miss any of the videos I am going to provide you on this channel. Thank you everyone for watching this video till the end. Thank you.